Welcome you all. I would like to welcome Professor Dr. Ajit Abraham on behalf of Life Made Up of Questions for this interactive session on the changing pedagogy in engineering education as per the new NEP 2020, because there has to be a transformation from traditional methodology. So first of all, I would like to welcome you.
Thank you, Dr. Hari. Thank you very much.
Let's have a brief introduction about Professor Dr. Ajit. It's very long profile, so I have made it very short. So Dr. Abraham is the director of Machine Intelligence Research Lab, that is MIR Labs, a not-for-profit scientific network for innovation and research excellence, connecting industry and academia. The network, with headquarters in Seattle, USA, has currently more than 1,500 scientific members from over 105 countries. As an investigator, co-investigator, he has won research grants worth over 100 plus million US dollars. Currently, he holds 2 university professional appointments. He works as a professor for artificial intelligence in Innopolis University, Russia, and in the Yayasan to Ismail Muhammad Ali Professorial Chair in Artificial Intelligence of UCSI, Malaysia. Dr. Abraham works in multidisciplinary environment, and he has co-authored more than 1,400 plus research publications, out of which there are 100 plus books covering various aspects of computer science. One of his books was translated to Japanese, and few other articles were translated to Russian and Chinese. Dr. Abraham has more than 46,000 plus academic citations, H-index of 102 plus as per Google Scholar. He has given more than 150 plenary lectures and conference tutorial in 20 plus countries. Dr. Abraham was the chair of IEEE Systems Man and Cybernetics Society, a technical committee on soft computing, which has over 200 plus members. During 2008 to 2021, and served as distinguished lecturer of IEEE Computer Society, representing Europe, 2011 to 2013. Dr. Abraham was the editor-in-chief of Engineering Applications of Artificial Intelligence during 2016-21, and served the editorial board of over 15 international journals indexed by Thomson ISI. Dr. Abraham received PhD degree in computer science from Monash University, Melbourne, Australia, 2001, and master science degree from Nanyang Technological University, Singapore in 1998. And the best thing is that he is from God's own country, Kerala, India. So I would like to welcome Professor Dr. Ajit Abraham. It's a very long profile of research. We used to see a linear graph without any cutoff or saturation. It's still linear. So welcome you, sir.
Thank you, Dr. Hari.
Yeah, so let's start the interaction, because his profile, like, it's very long profile, really fascinating, and really youngsters must be more enthusiastic on seeing the profile. So how, first of all, sir, how do you find time for doing a lot of researches, and how we are motivating yourself to engage into these research activities?
I guess it is a very difficult question to summarize it in few words. I think the first place, I enjoy what I do, and research is sort of my passion. And I've been, doing this now close to 25 years. And since my undergraduate degree, I was in the industry for some time, and then I, was introduced to industrial research environment, which I found, probably it is not very suitable for me. And then I, decided to pursue graduate research master's degree in NTU Singapore, where I got to get a first feeling of artificial intelligence. And that is when, I really, had that deep passion for knowing more AI, and I went to do further studies with Monash University, did my PhD, where I got to do wonderful things, focusing on various novel aspects of AI and its applications. And this was, imagine this was like in the late 90s. So basically, like AI was, sort of like, it was there, but it was not so popular, but it was there. So over time, I got to learn a lot of problems. So basically, AI is about problem solving, and I like challenges. So I got to learn new problems, visiting labs, knowing people, attending conferences, reading papers, getting to know a lot of new innovative products, and try to see how AI could be used, etc., etc. So I think it is like a chain process. It goes on, and I think the key is a passion, and I think the second is a purpose. So I think I feel like every human should have a purpose when he or she is born, and I think we have a purpose, and I feel that my purpose is to serve the community in the best possible way, and I chose education as a part of that. And educator, it is one of the fantastic jobs where and not only you learn, but you also teach others. So I think like I enjoy what I do, and it keeps me going. And I still feel that I'm like a small kid. I always quote uh, uh, Isaac Newton's quote, like I am a small child playing with stones in the shore of the ocean, where the whole ocean is in front of me, vast amount of knowledge. So I'm still a small boy trying to pick small knowledge here and there, and I think we have to go a long way, like even to understand something, a good aspect of science, we still have to go a long way. So I wish with my efforts and with my collaborators, students, and all of you, like I'll be able to learn more, and we'll be able to contribute more to the community.
Beautifully said. Actually, on going through your profile, actually, I was really motivated and I can feel that passion. So this passion, as Sir has mentioned, he has entered into a noble profession, like, and this passion has to be transformed to youngsters also. So, uh, how do you manage time for doing all these massive number of publications? It's really a needed question. Yeah.
This I get asked by like many people very often, because when they see my like CV, they ask me, Ajit, do you sleep? do you do you do some hobbies? Do you get time to do something else? So my answer is I get to do everything what everyone does. The only thing is all depends upon how we manage time. It's all about time management. I think one of the a key aspect is setting goals. Once you break up your like your projects or challenges into different goals, and then you focus on that. Like you should not lose focus at any time. Then prioritizing, you may be dealing with many things at the same time, but you need to prioritize. It's important, which is not important. And I think another key aspect is being well organized. That is very important, because once you are unstructured, like it is very easy to get loose, and you get disturbed very easily. So if you plan things well in advance, removing all noise, like all non-essential things, social media, all like all these disturbing things, and being self-aware of what you're doing every day, every hour. Basically, you can manage life, you can manage hobbies, you can manage So I think it is all about time management. So there is no hard secret, and I think I should probably acknowledge, like I usually communicate very well with my collaborators, my students, with whom I work with. So basically, it is more like a long term relationship, rather than like a writing paper and forget. We keep on doing things. So basically, I have collaborators since the last 20 years. So basically, we keep on doing research, writing papers. So we enjoy, our wavelength is very tuned, and we enjoy in our company exchanging ideas, writing papers together, like going one step ahead. So I think I should be also thankful to my close collaborators for keeping me going. Not only like we keep going together. So more than the things which I mentioned earlier, I guess I should also be thankful to my collaborators.
Yeah, I think the main important aspect is the passion itself, because you are loving your profession and you are not feeling the boredom. Because if you are you are enjoying and doing. Many people are forcefully doing. So that difference is there. I think that's make you more energetic always into this profession. So this is one of the most relevant question. What are some advices for youngsters to becoming good researchers from your? What advice would you like to give to youngsters to be a good researcher?
Well, I think it depends on which level we look at. Like for example, I guess nowadays we can see students doing research at undergraduate level. For example, in BTech or BS courses. For example, when I was an undergraduate student, I never knew what is research, and I never knew what is a publication. But nowadays, our kids are so lucky, that they got to get, like firsthand knowledge of latest technologies because of the connected world. Even though it is not part of the course itself, they can always find anything and everything they want from various sources. So I think that is like a very very good opportunity for them. So I think developing that passion, I think that is one key thing. Developing that passion to do research. Never do research for the sake of a degree, for the sake of a job, for the sake of a promotion. That will not take you in the long run. It will be more like you're like a candle in the ocean shore. Probably it will just light off within a matter of time. But if you are a small candle inside a small room, that is good enough. Like enjoy what you're doing. Like provide define some themes, some research areas which you're interested, or some problems which you're interested. Then try to zoom in and understand what are some of the challenges within that problem area. And then try to try to read some literature, try to read papers, ask your colleagues, discuss with your friends. Okay, network. Nowadays you have social media, you can discuss with anyone around the earth. So basically you can get a lot of ideas from here and there. And then like try to like summarize what you read, try to put in the form of like a small write up. And then probably like you can further discuss with someone who is more knowledgeable. Probably if you're in a college, can discuss with the professor whether this is something good or whether this is something bad. So this is something something for very basic research. And when you go to advanced research, for example, like doing a PhD, probably you need to define a theme which should stay for at least 10 years. Like you should pick a topic which should stay for 10 years. And also something which is well doable, like within a span of 3 to 4 years. Like if you look at everywhere there are problems, but you cannot solve all the problems. So basically you need to restrict the problem dimension so that you can solve this within the span of 3 to 4 years. And for that needs some understanding of the problem and also some guidance. That's why many people have supervisors, or especially students have supervisors, because supervisors are more experienced. They know if there's a problem, and if the methodology, it will take like 2 years, 3 years writing a thesis, defending it, all these formalities, and it will take another 6 months, 1 year. So basically supervisor will be able to guide things better in that aspect. Coming to a postdoctoral question also is very similar. Define a problem which is very challenging, which will also challenge your PhD itself. Like it is more interesting, and it will stand for some time, and also it will also lay some foundation for like part of your career. They're coming to academics, like for example, a junior academic to senior academics. I think I will go back to that passion thing. Like we should have that passion. We should never do research for the sake of research. And I think once you have selected education as your profession, teaching and research is more like two sides of a coin, but it doesn't stay alone. For example, you cannot be a good uh, teacher without doing research, or you cannot be a good teacher without doing teaching. So basically, if you're doing research, means you're able to develop new knowledge, you're able to understand new knowledge, you're able to find new knowledge, and then you should be also able to teach this to students. Only then it will have value. At the same time, if you're only teaching, for example, if you're teaching, for example, basic artificial intelligence course, and unless you know what is going on in the current world, what is happening with various applications, you'll not be able to teach the students the latest cutting technologies. And imagine when these students graduate, when they go for interview, and this employer asks the student, what is this, and student doesn't know what is it, and then it goes back to the teacher as well as the college and to university. So basically, it's important for teachers to do both research and teaching. Like in most Western universities, it is mandatory for any professor or any academic, to have that balance between teaching and research. So I guess I gave very a quick overview, about how to be a good researcher, from basic to advanced in a very, very, very nutshell. I guess if I have more time, I can elaborate more, but I think we don't have much time. So basically, I would suggest we can have a more detailed talk another time, probably, because this is a very interesting topic for me too. So we can have another detailed discussion another time.
Yeah, it was really eye-opening because I myself got some idea, because as Sir had mentioned, that balance between teaching as well as research, and still the base is still that passion which drives towards forward. Yeah. So let's start from the career of a career starting from 10th standard, 12th, then going to degree. What's your opinion, sir? For example, if a student doing 10th, he or she may not be knowing about what is their passion or what is their talent, which group they have to take. So what about engaging themselves into some hobby labs like AI, data science? Earlier, we are having some circuits in electronics for you magazine and all. So what is your opinion regarding students engaging in such hobby labs, identifying their passion?
I think that's a very, very good idea, and I think many countries and many universities have already, started this and already implementing this. For example, in the UAE, there is there's a minister for AI, there is a university for AI, and I myself, I am working in a university for IT, which is again focused on AI in Russia. So basically, the world is going in that direction. And it is important, for us to understand, the future is, going in that direction as well. For example, in the US, every 70% of the kids who graduate, they actually get some training in AI. So basically, they try to find that without AI, data science, they cannot, use any of the things they studied in a real world application. And starting this early, I think early the better. I would say even high school, probably, if you can inject, some basics, because AI is all about, if you look at, from another dimension, AI is all about another form of mathematics. So mathematics is all of, you're defining things using various mathematical concepts, equations, models. And in the case of AI, we are trying to solve problems where mathematics fails. So basically what AI could do is it can actually provoke thinking, students or kids can, have a different way of thinking. It can actually, increase creativity, like having, when they see, AI applications, nowadays, if you look at, if you just look around, and you could see tons of applications. And imagine if these kids themselves, they try to get a hold of, like a small robot, or, or a small app, they get to understand, how, what these things are doing in real life. And basically, we are also developing their entrepreneurial skills. Basically, they can come up with software products, start their own industry, once they get into a nice stream, graduation, okay, or even before that. For example, like if you look at Microsoft, or like Apple founders, they were all or even they couldn't go to complete a graduate degree or even a university degree, but they were, they started their life much early with, like hands-on programming, and they got to, learn how to talk to computers, that is the best way to talk to computer, right? I mean, using codes. So if you can learn that at a very early age, that can really, uh, 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 improve, your skill sets, and especially for good future. And more than that, I guess, this is my personal perception. uh, Nowadays, we are seeing, we are seeing a lot of things being replaced by machines, and I guess, like kids get to also learn, moral values, what is, ethics, what is good, what is bad. And I think in the long run, once these kids start, getting the opportunity to learn AI data science, I think they are also in a fast track for good job opportunities, and also, like even for higher studies. And like I mentioned earlier, AI data science, is more like a fabric. You can use this framework anytime, anywhere. As long as you have a problem, you have a system, you have a model, you can use AI data science. Okay, so basically, it helps, like a early exposure for, for the kids, if they can have the chance. So I always encourage, like even from high school, if you can, get the small doses, of courses of AI data science, that can, we can slowly, get them trained, and probably when they get to, college plus 11 plus 12, they can do, small projects, like small projects, even, like summertime, or or like when they have holidays, they can engage in, and then, get hands-on and experience of some AI tools, and then they can, they like select their specialization. Even I think probably in the coming years, probably we'll have more specialized AI degrees even at undergraduate level. So I hope, it will be very useful.
When coming to the +2 level, they're having science streams, commerce, humanities. So other than the science students, for the commerce as well as humanities, they can also do some hands-on courses in AI. They can also club this technology with the subjects. Is it possible? Like anything?
Definitely, I think it is highly possible, and basically, I always encourage non-science students. Probably they might not be able to, enjoy as much a science student would do, because if you look at AI data science, and if you want to understand a bit deeper, you need some good foundations, about mathematics. Some sort of, some mathematical understanding is required if you want to have a good grasp of the subject. But if you want to use as a tool, as an application, or use as a service, like if you want to use AI as a service, for solving some problem, or like plugging into an application. Basically, that is what all these data scientists nowadays doing. Basically they're not qualified, graduates, or having, like a degree in AI, or like a graduate degree in AI or research degree in AI. But basically, they are just doing some certifications, and mostly it's developing, on their own, doing some hands-on experiments, and getting hands-on experience, and playing with problems, etc. So I think it doesn't matter, whether, like the student is from commerce, or even from, arts. I think it really doesn't matter. The key is that passion to learn AI. And if you look at AI in a very deep way, you can see AI application commerce, for example, in stock markets, in banking, even in, like securing all these, financial markets. So basically, AI is everywhere, and even there is AI for even arts, for drawing paintings, or like creating design. So I think, the applications are, like it is very, uh, unimaginable, I would say. Like we cannot, simply really think about, like nowadays the world is going in that direction. So I guess anyone who wants to learn AI, they are always welcome, because there are a lot of opportunities.
Many of the students used to ask these questions because when they're going to enter into the graduation, they would like to do some preliminary courses on AI, data science, or other new technology. So, what is your opinion, sir? If there, what are the courses available for them to do? Some base foundation courses while before pursuing their graduation in AI, whether they're taking mechanical, electronics, electrical, civil, or any foundation, any fundamental program. Along with that, they can do this AI or data science. So before entering into their graduation, what type of courses will be suiting for them?
Well, there are, there are different ways for acquiring knowledge. One is reading classical books, classical papers, classical, like textbooks written by, famous authors. One way to start. Another way is to go online, try to, find online courses. They are basically a lot of free courses, totally free courses where you can get, get the materials, you can study on their own. For example, like Google AI platform, even Stanford University is offering free AI courses. Columbia University, NVIDIA, they're offering AI courses for using a GPU, etc. MIT, I'm talking about in a big schools. They are even offering free courses. The problem comes when you need certification. When you need a certificate, then probably you need to pay for it. And there are also several other free university courses. I just mentioned about some top universities, but also there are several free courses. If you just search on YouTube, some lectures and focused on AI. If you have some topics, for example, like machine learning, deep learning, decision trees, artificial neural networks, fuzzy logic, optimization, okay, a digital ecosystem. You just type in, you can find lectures. Nowadays you can find all this very easily. And I would suggest, once you pursue to read these lectures, or try to join some course, you also need to have hands-on experience. That is a mandatory requirement for AI and data science. Unless we do by ourselves, it is very difficult for us to understand. For example, I will say, machine learning is like this. You have supervised, you have input, outputs, you have, so basically understand it. But unless, you do this, by yourself for a problem or for an application, you get to understand what is a training error, what is testing error, and how can you minimize this error, what sort of model I'm using, how to get a better model, or how to use, change to something else, or whether AI would work for this problem. So all this, unless we do hands-on, and unless we have experience, and we cannot have a better judgment. So attending course sets itself is not enough, but we also need to play with our own hands. I would say like that. So unlike, for example, like arts, if you read, if you can remember and recollect, and if you are creative, probably you don't have to read again. Go for exam, you get very good scores. But AI, if you attend a lecture and if you go to an exam, unless you do by yourself, you probably might end up with 0 or very poor grades. So that's a difference. So unless we do by ourselves, so basically we need to dedicate time. There are several short courses from 3 months to 6 months, 1 year, but all these courses, as I mentioned, you need to dedicate time, and also you need to focus. The AI is a very big area, data science is a very big area, so you need some focus. What area in AI you want to learn, okay, and what is the objective, okay, you need to define, and then search around, and then look for some course. And like I mentioned, you can go for university courses, you can go for some company certifications. The options are many, and also there are several free courses on YouTube. So basically, I think the sky is the limit. We just need to do some simple search and focus on.
When a student is enrolling for the BTech program in any colleges in our country, so how they can join hands-on with this add-on program? Like as sir has mentioned, the hands-on experience must be there. So preliminarily, when they're in first year, they are just going through the fundamentals. So along with that, it's totally into the research side, like mathematics is coming. So what are the foundational courses required for developing the aptitude towards AI programs?
Well, I think if they're, if they're in the engineering stream, definitely, I would say that, they will have, at least some fundamental, math background to pick, basic AI and like slowly develop. But I think, learning someone on its own, while continuing his or her, like mainstream course, it can be a challenge, probably, like unless, the student is so passionate about learning, and probably, he or she might need some guidance. So unless, we go for some structured courses, so there is some structured course along with the semesters, like every semester, like you have in a small module, or a small course on AI, and then like over time, like first year you do this many modules, second year this many modules, and then you add on, and probably, after 4 years of undergraduate degree, the student also, gets, it's like a side major, like in AI. So that is something, which we are planning to do like 2 years ago, but apparently, COVID came into picture and we had to, call it off, for these years. But I think we still have some plans to get back to that level. So I think, like always there is a need for some guidance. Of course you can study by yourself, but I think if you want to, go a bit deep, like just like you mentioned, if you want to have hands-on, basically you need to develop some programming skills. So basically you need to do some structured programming courses, and programming courses, unless, like, of course, so someone can do by himself or herself, but definitely if you have guidance, it can help the student a lot better. So I think some structured guidance would make sure that, that there is some quality, and the student also, gets some, clear knowledge, and he or she is equipped with the basic AI skills and ready for industry. So for example, if a student, in mechanical engineering, and if he or she, like studies AI, data science, as a side stream, and like once he or she finishes the degree, even he or she can go for an IT job. So basically, like we are seeing this right now in the industry. Like a lot of mechanical engineers are going for IT jobs. A lot of civil engineers are going for IT jobs. So we are actually, seeing all these things happening. So I think, this is what the future is, because if you look at, like any engineering stream, there is a tight connection with information technology. How information technology is helping those industries. And AI data science is more like a fabric, try to understand, trying to, like, it's more like in a user interface between the problem and the technology. So basically, AI usage, is a must in most of these engineering streams. So I would say, like it's a good idea, for any stream, even management, even law. I guess, sky's the limit for even for doctors, medical doctors. Nowadays, healthcare is a very, very, very important area, where there is a wide gap, because doctors know what is going on. At the same time, the computer scientists, know data, but like between them, so there's a big gap. And computer scientists, learning medicine is sort of very difficult, but for doctors, understanding basic computer science, basic AI is sort of very easy, and probably they can, like even like team up with some computer scientists, develop applications, solve, like complex problems, etc., etc. So I think such sort of, like collaborations are mandatory, because AI is more like a multidisciplinary science. So I think, if you can start from early stage, like first year undergraduate, probably that is the right age. Probably we would see, like a lot of kids, trained in a multidisciplinary area, right from the college.
Yeah, as it seems, it's having very good scope in interdisciplinary research areas. So when it's come to the computer programming, when students from biology as well as computer science or biotechnology may be joining engineering, and they will be having some foundation on C, C++. So what programming language mostly used to understand the basic fundamentals of AI?
Well, like even, like for example, for me, if someone who has proficiency in C, C++, then AI is almost nothing. Like I would say, picking up AI would be very, very easy. What really matters is a student who is totally, like there is no fundamentals, on or about programming. Then we will have a problem with some, like foundational programming. So I would say, like for example, nowadays there are a lot of libraries in Python, in R, which is sort of like very easy. Even you don't have to be be a very good programmer, but if you are good in C, C++, you can understand things a lot better. So it is more like when you're doing cooking, like if you're buying like a spice mix, or if you're buying ingredients, how to use what. So if you know programming, you can mix what you want exactly and then do what it is. But if you're buying spice mix, probably you're using more like libraries, you just need to call the function and execute it, but you don't know what is going on inside. So it depends, depends upon like the background. And even like Python and R, there are several levels of courses nowadays, like from crash courses to advanced course. I think if someone can spend a 1 year like dedication, probably he or she can really master like one of the AI programming languages like Python or R. And there are also, like I mentioned, it is not necessary to do all this hardcore programming unless you want to do some real developments in the industry or for doing research. There are also like many services, for example, with like Google Cloud, like TensorFlow. There are like various cloud-based services. You just send the data, send the commands, and you get the results back. So AI, is more like going in that direction. So it depends, like what the student or like researcher wants to achieve, and how much time he or she wants to commit towards this.
Nowadays, we can see a lot of courses on AI. So many students are totally confused. Actually, what is AI? Because embedded system, we are having our car, the functionality, everything is electronically equipped. Everything is going to be smart. The collaboration, like everything is an embedded system. So how can we differentiate the AI? What is the main thrust of AI? Totally, students are confused. What is AI actually? They are totally confused in such a situation.
Well, like I would say AI is more like a problem solving methodology. Like I mentioned earlier, like certain problems we cannot solve using mathematical models. For example, like if you want to like categorize like birds and animals. Okay, so basically imagine you have nice features and you're trying to categorize them. And like imagine if it is very easy, you can actually put a straight line, right? Y is equals mx plus c. It is high school mathematics. But imagine if you want to categorize different birds, then probably like it is not possible to draw a straight line there. Probably we need to like join these lines at some points, not a like a line with a single slope. Then we need more complex learning methods. So we might need some sort of like I would say machine learning or advanced learning schemes, which can actually automatically learn that hyperplane. So that is all about AI. So AI deals with various aspects. I would say like one major aspect is about function approximation. Like you have some inputs, you have some outputs, and you need to build a model. For example, you have like for example today's weather. Like what is the weather today and what will be tomorrow's weather. It's more like a prediction. Okay, you're getting an X-ray, like of a COVID patient and a non-COVID patient. So you need to distinguish between these two categories. Okay, so that is more like a classification. Similarly, like you want to group together, for example, like students who goes to this college, students who goes to that college, like you want to cluster them, clustering. Okay, so functional approximation is it's one of like a major aspect within AI. Then comes approximate reasoning. Approximate reasoning deals with vagueness. Like for example, now I say Dr. Hari is a tall man. Okay? But when I say when I say this, and people will think like, wow, probably Dr. Hari is like 170 to 170 centimeters in India. But if I say this to a Norwegian, probably he would say Dr. Hari is more than 200 centimeters, because in Norway, like everyone is tall, and like when I say very tall means, it means that it is above average. So we humans, we can communicate using words, and we understand that very easily. So how can we make a machine understand that? Okay. So that is all about approximate reasoning. Okay. So, and it can be used in several problem domains. And there are also rule-based systems. For example, like we usually transform knowledge in the form of rules. For example, like if I want to convey to a student how how was the past exams, like in a subject, and then I will use some rules, right? It's questions can be from this area, then it is like this, like even for crossing the road, and we will say the road is safe, or the traffic light is red, then stop. If the road is like safe, and if the traffic light is green, then you can cross. Or if the road is red and the road is safe, still you can cross. And we use rules. So all these rule-based models, and then you can also incorporate approximate reasoning within that. Like, so basically you can make very good human-like intelligent systems, which can be useful in like several applications. Another big area is the field of optimization, where we want to like make something better. For example, what is the best shape of a pen? Okay, can someone answer what is the best shape of a pen? No one knows, right? Whether it is like the looks itself, or whether it is the cost, whether it is the life, whether it is weight, okay, whether it's a combination of everything. Okay, so certain things that we humans, we don't know what is the best. So AI deals with finding solutions that we humans can understand, and we can tolerate. For example, parking a car in a garage. Okay, if you ask in a robot, and if you say that like you should park the car within 5 centimeters from some line, the robot will do that. But it is not necessary for the robot to park the car with such precision, right? Because it takes a long time for such precise movements. As long as the car is parked inside the garage, it should be all right. So like making such decisions from uncertainty, imprecision, etc., etc. So I think these are some key challenges how AI differs from conventional mathematical models. So like these are I would say some summaries. And again, there are some models based on multi-agent systems. Like for example, there is no human, but you need to make decisions. So for example, in outer space, you're sending a robot like rover. Rover has to make decisions. So basically, you have sort of like a multi-agent systems. Basically, you have a software which you incorporate knowledge within the software, and then it actually helps to make decisions by itself. So it is basically it works more automatically without much human intervention. So you could see such models, for example, in cybersecurity. Like in various applications, and nowadays, like this is I always receive complaints from other scientists. For example, computer vision. They say that it is computer vision, but AI say that it is AI. But we have to understand like it is more like a compromise. Like for example, you have driverless cars, but again, computer vision plays a very important role there. You basically need cameras and transform all the images, make the right object recognition, and then AI is only a categorization, whether it is a stone, whether it is something, a plastic cover, you can go over it. So basically, decision making is very simple, but computer vision comes like a major part in that. So sometimes it is not only AI, but also you need supporting roles from many other aspects. And data science deals with understanding data, both structured and unstructured data. Structured means, you have, for example, like an Excel sheet. You have well-defined fields like age, city name, country, educational qualification, like job, salary. That's all very structured. Imagine, you have like a graph, for example, like Facebook. You have like thousands of friends. Twitter, you have like 1 million tweets in an archive. You want to find what is this archive talks about. Okay. Imagine, this conversation we are having right now, the Zoom meeting, and someone don't have time. What Dr. Ajit and Dr. Hari talked about during this 45 minutes. I don't have time, but I want to summarize. Okay. How can you summarize this? So, like data comes in different forms, and, we need to use appropriate data science methodologies to understand what is inside. And that is all about data science. So AI and data science, plays more like a marriage, husband and wife. So, to me, both exist together. There is no independent existence. So for solving problems, for, taking on applications, we need a right combination of both. And that is why we are seeing like a success story of both these technologies in various applications.
So AI can be used as a combination with all the fundamental branches in the case of developing new projects.
Definitely, yes.
So, sir, coming into the objectives of MIR Labs, that is Machine Intelligence Research Labs, what is the main objective and what are the projects undergoing with MIR Labs?
Well, basically, this was formulated in 2008. So basically, it is a not-for-profit society. We are aiming for progressing research by collaboration and networking, and beyond university boundaries, beyond state boundaries, beyond national boundaries. Basically, we are looking for even for intercontinental type research projects. So basically, we do projects which are aimed for advancing science. So basically, we do a lot of funded projects, mostly funded by governments, science foundations, etc., etc. And basically, we collaborate with universities and industries for solving such a grand challenge problems and applications. So basically, like most of these funds, like since they come from government sources, so basically we also collaborate with a lot of industries. So basically, we are also solving a lot of real world problems, from drug manufacturing to networking to medical imaging. So like there are a variety of problem dimensions where we are using different AI tools. So like we have we have executed a lot of projects in the past, where we have developed a lot of interesting methodologies. If you look at some of our publications, you can find them, and what we did and how we did, like who are our collaborators. So basically, Middle Labs is more like a fabric for doing advanced research at a very big scale. So basically, we are looking for collaboration of universities and industries. So basically, for a project, usually we have usually 5 to 8 industries and usually 3 to 5 industrial partners. So usually, it's a big team size, and usually the project runs from 2 to 4 years at an average. And there are several success stories, which I think I would need another 1 hour to explain. But I think that is all about Middle Labs. Basically, a framework for doing cutting edge research at a very low cost and like without much overheads.
Yeah, on hearing the main objectives of Mirror Labs, I think focusing to the NEP 2020, the new education policy, like we have mentioned in the title, that moving from the traditional teaching learning methodology. I think such research collaborations would be helping students, right, on forecasting to the next 10 or 20 years. Sir, what do you think? What will be the education system and what are all the transformations going to happen?
Definitely, I think it is very difficult to like predict what can happen after 20 years. If we look at 20 years before and now, certain things have happened in a very unimaginable way. Even education, if you look at education, 20 years ago, and if I want a paper, I need to, like for example, when I was doing my PhD, if I want a paper, I had to wait for like 1 month, like because the library sends a request usually by fax to some university outside, and then the university, they will like get approval from the department, and then like they print the paper, and then like, or make a photocopy and then send to us by post. So usually it takes 1 month. But now like even a housewife can get any paper from the kitchen. So basically education has changed to such level. Anyone from anywhere can learn anything from anywhere. So education has become like in a very different way. And not only education, like if we look at like e-commerce, we have like Uber. They don't have a single car, but they are one of the biggest taxi companies in the world. Similarly, Amazon, they don't manufacture many products, but nowadays they're manufacturing. But in the beginning, it is more like Uber. They have a platform, and then like they sell things, and they became one of the biggest like e-commerce company. Alibaba, likewise Airbnb, biggest hotelier. So like with AI as a fabric, I think it is very difficult for us to predict what can happen after 20 years. But certainly I think a lot of good things are going to come. There is no doubt about it, especially in manufacturing. We would see a big difference. Right now it is ongoing. For example, from massive production, like we are moving towards mass customization. For example, if you want to buy a shoes now, if you go, you might have to go to a shoe store and get what they can offer. But imagine in the future, you can actually order, like a particular shoes where you want to design like this, and then you do everything online, and the customer, the manufacturer gets your order put into the manufacturing line. The robots does the like the production, and you get the pack within a few days at home. So like it is like it is very difficult to predict what all things can change in a very big scale. War fighting, we are seeing like the ongoing war. We are seeing how technology is playing a big role. Like without much human intervention, a lot of high level intelligence. At the same time, a lot of war fighting also going on with all this like AI related technologies. Similarly, transportation, like transportation is taking a big toll, from driverless cars to advanced levels. Even entertainment industry is changing a lot because of these technologies, virtual reality, augmented reality. And I think in education sector also, like these technologies like virtual reality, augmented reality could change like put a big role. And especially I think during these COVID times, we were able to make use of some of these technologies, to make kids understand, and even working in the lab, being at home. So I think for me it is very difficult to predict what will happen after 20 years. But I guess it will be a nice journey to get there, and let us hope for the best.
So thank you, Professor Dr. Ajit Abraham, for spending your valuable time on sharing your experience, your vision, your concept on AI data science, which will be very beneficial for the student as well as faculty, and making use of it. Because I really enjoyed this talk, because if a student is able to understand the main application or the concept before learning the fundamental or the mathematics, it will be really creating the passion. Sir is still maintaining that passion, and we can see the graph is still linear, and we are expecting much more publications, which will be beneficial for the society, for the faculty, for the research and development, for the university, for the student community, and whoever it may be. So I wish all the very best wishes for Mir Labs and the ongoing projects of Mir Labs, and for your educational career also. So thank you, sir, for sharing the screen and spending your valuable suggestions, your experience. Thank you. Thank you.
Thank you. Thank you, Dr. Hadi. It was nice meeting you, and thank you for all your efforts in this direction. You're also doing a wonderful service to the community, and I hope that you will continue doing this and transform this knowledge to a wider community. So thank you very much. Take care and stay safe.
Thank you. And once again, thank you. Because of your help only, we are able to engage some programs, because always some good visionaries should be coming. So thank you, sir. Thank you.
Thank you. Thank you again. Thank you. Goodbye.
Thank you. Bye-bye.